Imagine this. You step off the lander onto the rusty red soil of Mars. Your boots crunch through the fine dust and gravity that feels strangely light, only about 38% of what you're used to on Earth. The sky above glows a pale butterscotch color. And far off in the distance, Earth is nothing more than a tiny, faint blue point of light. For generations, humans have looked at that red dot in the night sky and dreamed the same dream, turning Mars into our second home, a place where humanity could expand, a backup for our species if things ever go wrong on Earth. But here's the question that keeps scientists up at night. Is Mars colonization a bold, inspiring dream, or could it turn into a deadly trap for those who try? Mars has always seemed like the most promising candidate. It has a day almost exactly the same length as Earth's, about 24 hours and 37 minutes. There's water ice locked away in the poles and underground, and the planet is covered in raw materials that could, in theory, be turned into air, fuel, and building supplies. It feels close enough, reachable enough, that the dream keeps pulling us forward. But step onto the surface, and the realities hit hard. First, there's the air, or rather, the lack of it. Mars's atmosphere is incredibly thin, only about 0.6% the pressure of Earth's, and it's made up of roughly 95% carbon dioxide. You couldn't breathe it for even a second. It offers almost no protection from the harshness of space. Then, there's the radiation. Without a strong global magnetic field like Earth's, and with such a thin atmosphere, cosmic rays and solar particles reach the surface largely unshielded. Measurements from NASA's Curiosity rover showed astronauts on Mars would receive an average of about 600 to 700 microsieverts per day. That's roughly 40 to 50 times higher than the natural radiation most people get on Earth in a year, accumulating day after day. Over months or years, that kind of exposure raises serious long-term health risks, including higher chances of cancer. Gravity adds another layer of uncertainty. At just 38% of Earth's gravity, your body would feel lighter. You could jump higher, move more easily at first. But over time, that reduced pull leads to muscle weakening and bone density loss, effects we've already seen in astronauts spending months in microgravity on the International Space Station. What happens when people live there for years? What about children born and raised in that environment? We simply don't know yet how low gravity affects human development, reproduction, or long-term health across generations. And then, there are the environmental extremes. Average surface temperatures hover around -60 degrees Celsius, with swings that can be brutal. Global or regional dust storms can kick up fine, abrasive particles that last for weeks, sometimes months. These storms can block sunlight, coat solar panels, and grind away at equipment and seals. Landing itself is one of the toughest engineering problems. The thin atmosphere makes it incredibly difficult to slow down heavy payloads. Technologies that worked for smaller robotic rovers don't easily scale up to the tens of tons needed for meaningful human outposts. Getting people and supplies safely to the surface without burning up or crashing remains a massive hurdle. Even if you survive the journey and the landing, isolation would test the human mind in ways we've never fully experienced. Radio signals take anywhere from 4 to over 20 minutes. One way to travel between Earth and Mars. That means conversations become delayed messages. No real-time help in an emergency. Studies from isolation analogs on Earth show that long-term confinement, delayed communication, and the psychological weight of seeing Earth shrink to a distant speck can lead to stress, depression, and crew tension. There would be no quick rescue if something went wrong. So, does all of this make Mars a death trap? Not necessarily, but it does make colonization brutally difficult. The deeper problem isn't just Mars. It's that everything about us, our bodies, our technology, is designed for Earth. From the air we breathe to the pressure our systems rely on, none of it exists naturally on Mars. So surviving there doesn't just mean going, it means rebuilding everything to survive in a world that plays by completely different rules. Still, scientists and engineers are exploring ways forward. One promising idea is using natural lava tubes, ancient volcanic caves beneath the surface. These formations could provide natural shielding from radiation and micrometeorites, while offering more stable temperatures and protection from dust storms. Models suggest that living deep inside certain lava tubes could reduce radiation exposure dramatically, down toward levels much closer to what we experience on Earth. Another step is learning to live off the land, what engineers call in situ resource utilization. NASA's MOXIE experiment on the Perseverance rover proved the concept by pulling carbon dioxide from the Martian atmosphere and turning it into oxygen through electrolysis. In its best runs, it produced up to 12 grams of oxygen per hour, twice the original goal. Scaling that kind of technology could one day help make breathable air and rocket propellant on site, reducing the need to ship everything from Earth. Private companies like SpaceX are also developing spacecraft designed for repeated missions between Earth and Mars, a crucial step if any long-term human presence is to become realistic. Early habitats would likely need to be buried under regolith or placed inside those lava tubes for protection. Progress would have to be slow and careful, starting with robotic precursors, small research stations, and closed-loop life support systems tested over many years. Mars colonization sits right on that knife's edge. It represents one of humanity's greatest dreams, becoming a multi-planetary species, expanding our reach and securing a future beyond a single world. At the same time, the realities of radiation, low gravity, a hostile environment, and profound isolation make it one of the harshest challenges we could ever undertake. It won't happen quickly. It will demand breakthroughs in shielding, biology, psychology, and engineering that we're only beginning to explore. Whether Mars becomes a thriving second home or remains too dangerous may ultimately depend on how clearly we see the risks and how determined we are to solve them. Mars won't change for us. We're the ones who have to change. So, what do you think? Is the dream worth the danger? Drop your thoughts in the comments below. Would you ever consider living on Mars? And which challenge worries you the most? If you're new here, hit subscribe for more stories about our place in the cosmos. Thanks for watching.